friends, in this video we are going to solve a problem on how to determine the solution of the time response of a time invariant system. So let's take a problem. So our problem is we have to obtain the time solution of y for the system which is given by x dot equals to ax plus bu and y equals to cx. This is the state model of the system, okay? And the values of the ABC matrices is given to us in the question. A, this is B matrix, this is C matrix. Now this is the initial state vector given to us, and the input is also given to us that it is 5. Okay. Now we have to use the straight transition matrix method for finding the solution. Now you can see that input is given to us, so this is a non-homogeneous system, and for non-homogeneous system we know the solution, we know the formula for the time response. Okay, so we will directly use the formula, then calculate all the variables in it and then substitute their values so that we can get our answer. Okay, so let's try to solve this problem. This is the formula for the time response of a time invariant system, non-homogeneous system it is. So we have this inverse Laplace transform of Si minus A inverse into X naught. X naught is given to us in the question. B is also given and US is also given. Okay, so we are going to first calculate this Si minus A inverse. For this we will first calculate Si minus A. A matrix is given to us in the question. So this is S multiplied with the identity matrix minus the A matrix. So its value is S minus 0. So S 0 minus 1 minus 1. Then we have 0 minus minus 3 is 3. And then S minus minus 4 is S plus 4. So this is Si minus A matrix. Now we have to calculate Si minus A inverse. Now inverse is calculated by dividing the adjoint with the determinant. So we will divide the adjoint of the Si minus A matrix with its determinant. This is a 2 cross 2 matrix, so we can directly calculate the adjoint. We have to just interchange these two elements and we have to change the sign of these two elements. This is the adjoint of Si minus A. Now determinant, just multiply S into S plus 4 minus of 3 into minus 1. Minus 3 into minus 1 is minus 3. Just solve it. S plus 4 plus 3. So it will be S square plus 4S plus 3. Now if we solve it, this is a quadratic equation, we can solve it. So its roots will be S plus 1 and S plus 3. So we will have Okay, so we have the SI minus A inverse. Now we have to use, because in the question it is given that we have to use the straight transition matrix method. Okay, so we have this SI minus A inverse. So we will first calculate the state transition matrix. For state transition matrix calculation, we have to take the inverse Laplace transform of this SI minus A inverse. Divide this. Okay. Now, for taking the inverse Laplace transforms, we should convert these terms into the standard form so that we can directly apply the formulas for the inverse Laplace transform. For this, we have to take the partial fractions so that they can be factorized, and then we can apply the formulas. So first, factorize this. Factorization is done by equating this with, suppose, A upon S plus 1 and plus B upon S plus 3. Then just take the LCM. If we multiply this, we will get AS plus 3A plus BS plus B. And this numerator part will be equal to the numerator on the left hand side. So it will be equal to S plus 4. Because denominator part is same, so it will be cancelled. Only the numerator parts will be equated. So we will have AS plus BS. These are the coefficient of S, that is A plus B. And here the coefficient of S is 1. So A plus B will be equal to 1. And the constant terms in this polynomial are 3A plus B. So it will be equal to the constant term on the left hand side. So it is equal to 4. We have these two equations and two unknown variables, so we can easily find out the values. Okay, so it will be equal to, if we take the negative sign, then A will be equal to minus 1 by 2. Sorry, it will be equal to, if we take here the minus sign here, then B, it will be cancelled. A minus 3A, so it will be minus 2A equals to minus 4 plus 3 minus 3. So A will be equals to 3 by 2. Okay. And from this we can calculate the value here. So A is 3 by 2 and B will be, put the value of A here. So B will be equal to 1 minus 3 by 2. So B will be equals to minus 1 by 2. So in this way, you can factorize all these terms and can convert it into the partial fraction form so that we can easily apply the inverse Laplace formulas directly. I'm directly writing all the values here. So this is the SI minus A inverse Laplace transform we have to calculate. We have converted all the terms into their partial fraction forms. Now they are converted into the standard expression, so we can easily apply the inverse Laplace transform here. This is our state transition matrix. This will be equal to minus 1 by 2 e raised to the power minus 3t. The inverse Laplace transform of this will be plus 3 by 2 e raised to the power minus t. Similarly, all can be calculated. So this is our state transition matrix. Now we have to calculate the second part of the formula, that is inverse Laplace transform of Si minus A inverse B U S. Okay. So first we will multiply these matrices and then we will take the inverse Laplace transform. Si minus A inverse we have calculated here. This is S plus 4 upon S plus 1. Then B matrix, it is given to us in the question, its value, it is 0 and 1. Then we have US. US is given to us, UT is given that it is 5. Okay, so we have to take the Laplace transform of it. So US will be equal to 5 by S, because the Laplace transform of a unit step function is 1 by S. So here it is given 5, so its Laplace transform will be 5 by S. So we will multiply this with 5 by S. So multiplying first these two matrices and then multiplying it with 5 by S. So this multiplied with 0 plus 1 multiplied with 1. So we will get 1 upon S plus 1, S plus 3. Then we have to multiply it with 5 by S. So we are going to get 5 by S, S plus 1, S plus 3. Then this multiplied with 0, it will become 0 plus S multiplied with 1, and then we have to multiply it with 5 by S. So S and S will be cancelled. We are left with only 5 upon S plus 1, S plus 3. So we have obtained this multiplication Si minus A inverse BUS. Now we have to take the inverse Laplace transform of this. So for inverse Laplace transform, we have to again convert it into the partial fraction form so that we can apply the formulas directly. So take the partial fractions here. This will be A by S. Okay, this is the partial fractions of these terms. Now we have to calculate A, B, C, D, E, these values. So just take the LCM, then equate this, what I have explained earlier, that how the partial fraction form can be obtained. So I'm directly writing the answer here, that we have to calculate the inverse Laplace transform of Now we can apply the inverse Laplace transform expressions here. So we will get 5 by 3s, so it will be 5 by 3 minus 5 by 2 e raised to the power minus t minus 5 by 6 e raised to the power minus 3t. It will be 5 by 2 e raised to the power minus t minus 5 by 2 e raised to the power minus 3t. So this is the value for this inverse Laplace transform of Si minus A inverse BUS. Now first we have written the formula for the solution of the time response of time invariant system. This is the time response. So we have calculated this part, we have also calculated this part. We have to just add these two so that we can get the resultant answer. First part, what we calculated is phi t into x naught. And second part was Laplace inverse of Si minus A inverse B U S. So phi t is, so we will substitute the value of phi t which we calculated earlier. Now this x0, it is the initial state vector and its value is given to us in the question. It is 1 and 0. Okay, so this value is given to us and this we have already calculated. So we will just write it here. First we will solve this part. So this is going to multiply, these two matrices are going to multiply. This multiplied with 1 plus this multiplied with 0. Okay, so this is our solution. Plus 3 by 2 e raised to the power minus t. Then this multiplied with 1 and this multiplied with 0. So we are going to get minus 3 by 2. Okay, plus this value we have calculated and this is the value. So we are going to substitute its value here. Now we have these two matrices and we have to add this so that we can get xt. So xt will be equal to, this is minus 1 by 2 e raised to the power minus 3t. This is minus 5 by 6 e raised to the power minus 3t. Then this is plus 3 by 2 e raised to the power minus t and this is minus 5 by 2 e raised to the power minus t. So we are going to get first 5 by 3, then minus e raised to the power minus t minus 8 by 6 e raised to the power minus 3t. Okay. Then we will add these two terms. So e raised to the power minus t, these will be added, minus 3 by 2 and 5 by 2. So it will be e raised to the power minus t. So this is e raised to the power minus t and then e raised to the power minus 3t terms will be added. So we will get minus e raised to the power minus 3t. So this is the value of the xt, that is the state vector that we have obtained. Now we have to find out the output also. Okay, so this output is equal to cxt. Now C matrix is given to us in the question. It is 1 0 1 1. xt we have already calculated, so we will write its value here. Substituting it, we will get so y will be equal to 1 multiply with this and 0 multiplied with this. So we are going to get 5 by 3 minus e raised to the power minus t minus 8 by 6 e raised to the power minus 3t. Then 1 multiplied with this plus 1 multiplied with this. So we are going to get, we have to add these two terms. So 5 by 3, then minus e raised to the power minus t and plus e raised to the power minus t. So they are cancelled. Then this thing, so we are going to get 5 by 3 minus 7 by 3 e raised to the power minus 3t. This is our output. So we have calculated xt and y for this system. So in the question we were asked that we have to find the solution, time solution on output response of the system, on non-homogeneous system. So we just taken the formula, we know the formula for it, and we are going to get, because we have to use the state transition method, transition matrix method. So first we calculated the state transition matrix, and then we substituted the value of all the variables in the formula and get the resultant time response. Then for output we know that y is equals to cxt, so we just substituted the value of c matrix and xt and then calculated the output response of the system. So I hope that this problem is clear to you. Thank you.